So piecewise functions are just pieces of functions where you have one piece for a specific interval and another piece for another interval. So this says you're using an absolute value function, but only for the left side of the graph. It says if x is left of 1, you're going to use your absolute value function. And then it says if x is to the right of 1, you're going to use a rational function instead. So you're going to be using two different functions depending on which part of the graph you're looking at. So what we're going to do is we're going to let our calculators kind of help us graph this. And so I'm going to take this. I have just cleared my calculator, and I'm going to press y equals and 2. And then anyone remember how to get the absolute value sign on their calculator? Math. Go over to number and press enter on number 1, which is ABS for absolute value. And we're going to type x plus 3 and minus 5. All right. And this first one has a vertex of what? What's the vertex? -3, -5. So that point is going to be important. Just in making sure that I get the whole shape of the graph. So I know I'm going to plot -3, -5. And I'm going to be plotting this stuff kind of light. Because what's going to happen is I'm going to graph the entire thing, and then I'm going to go back and I'm going to erase the portion of the graph that I don't need. That's how I typically teach students how to graph piecewise functions when they first learn. And then once you get better at them, you can start to just graph the portion that you need and not go back and erase. But the first few that you graph, it'll be easiest to just graph the whole thing and then go back and erase the part you don't need. So stay with me. It's not scary. It looks kind of scary, but it's not scary. So 2 times absolute value of x plus 3 minus 5. I'm going to go ahead and see what the graph looks like. Now I'm going to look at the table, and I'm going to look for -3, -5. And I'm going to graph the other points. So -4, -3, -2, -3. -1, -1, 0, 1. And since the important information here is that x is a value of +1, I want to make sure that my graph is big enough, that it goes to the left and right far enough that I go around x equals 1, that I make sure that part of the graph is actually graphed. So 1, 3, 2, 5. So I graphed that part. I'm going to just draw it in lightly for right now, not very dark. I can go the other way. -5, -1. -6, +1. So here's my V-shaped graph. So far, I haven't done anything crazy. Okay. We good so far? Okay. So now what we're going to do is we're going to take this x value, and we are going to circle where that x value shows up on this graph. So we have an x value of +1. I'm going to find the x value of +1 on this graph. It's right here. And I'm going to circle this x value of +1. So it's at the point 1, 3. I'm circling that. Now, based on this symbol, it says less than 1. It does not say equal to 1. So if it says equal to 1, I would fill in my circle. If it does not say equal to 1, I do not fill in the circle. Does that make sense? So I'm always going to look at this number. Wherever this number is, that's where I draw a circle. If it says equal to, I fill it in. If it doesn't say equal to, I do not fill it in. Okay? And then I look and I see which part of the graph that this arrow is telling me to keep. It says x values that are less than 1. That's to the left. So I'm going to keep the part to the left. I'm going to go back and I'm going to draw that line darker. And then anything to the right of 1, I'm going to erase. I'm going to get rid of it because it's not the part that I'm keeping. How do we feel about that first part? Good so far? Yeah. Yes. I think I actually put the extras over on the table already. Okay, the next one is a rational graph, which means it has a vertical asymptote and a horizontal asymptote instead of having a vertex or a locator point. So the vertical asymptote is at x equals what value? You're close. +1. We always do the opposite sign, right? And then the horizontal asymptote is at y equals -2. Okay, so I'm going to draw in the vertical asymptote. And I'm going to draw in the horizontal asymptote at -2. I'm not going to draw the horizontal asymptote going all the way over here, just because I don't think I'm going to be using this part of the graph since the v is already there. So I'm going to stop my horizontal asymptote just kind of like right in here. Okay, so I know that when I look on the table, I'm going to be looking for a point that's kind of near 1, -2 on the table. And that's going to help me figure out what other points I should be graphing. So let's go ahead and graph this. We have two ways to type this in. We can type this in as a fraction, or we can type it in not as a fraction. It depends what kind of outputs we want. So I'm going to go ahead and type it in like a fraction, because I think that's what most of you would want to do. Is that accurate? A fraction? Okay. So I'm going to type alpha y equals to get that fraction in there. And I've got the 1 on the top and x minus 1 on the bottom. 1 on the top, x minus 1 on the bottom, and then -2. And I'll go ahead and hit graph and look at my graph. So there's my rational function. I can see like 2 corners of a table. So it looks like a rational. And now I'm going to go ahead and hit second graph. And I'm looking approximately where an x-coordinate of 1 and a y-coordinate of -2 would be. I'm not going to see an x-coordinate of 1. That's the error message. That's for the vertical asymptote. But I'm going to be graphing points that are around that. So I've got 2, -1. So +2, -1. And then I've got the point 0, -3. 0, -3 right here. And then I know that the look of these is that they look like the corner of a table, and I know that with rational graphs, they just get really close to the asymptote. So if you're feeling uncomfortable with these being fractions like this, -3/2, -1.5, or these fractions actually aren't too bad. -1.5 right there. If you don't like those being fractions, there's 2 ways you could fix that. One way you could fix it is by typing this in not as a fraction, which I'll show you in a second. The other way is to go to the end of the equation, and you can hit the math button right here at the end of the equation, and you can go down to number 2, which tells the calculator, yes, I typed this as a fraction, but please turn my outputs into decimals. So now if you hit second graph to look at the table, it will convert all of these into decimals for you. And then they can be a little bit easier to graph. So that's one option you could do if you want your table to not be fractions. The other option is that when you type this, you could not type it as a fraction. So you could type it as 1 divided by x minus 1 in parentheses to show that that whole thing is on the bottom, and then type a -2. So I do not recommend this because most students forget the parentheses and then they get the answer wrong. So this is not my recommendation. My recommendation would be to convert your answers to decimals the way that I just showed you. And if you forget how to do that, I will always explain it to you. Hi. Do you need something? Okay, so let's go ahead and graph these. So we're going to take the curve and have it follow the asymptote. And then this one over here, I don't have other points, but it would do the same thing. Kind of follow the asymptote like this. And typically, if I could, I would tell you to find out on this graph where you're going to equal 1. Now, is there a point on this graph where you're going to equal 1? No. And that's because there's an asymptote in the way. So we're not going to be able to circle 1. So we know 1 is right in the middle, but we are going to be keeping the portion of the graph that is to the right of 1. So what should I do? Which part of the graph should I be keeping? This part or this part? The top part. So I'm going to take this one, I'm going to make it a little bit darker, I'm going to keep this one, make sure it looks like a final draft drawing. And then this one, I'm just going to erase. I don't need this one after all. That one was extra. So my piecewise function has two pieces. It has an absolute value piece. It has a rational piece. Two pieces. Now, yesterday we talked about something called continuity, and a graph was continuous if you could trace the entire graph without picking up your finger. So this graph has two pieces. If I was to trace this whole graph, I would trace the V, and then I would have to pick up my finger, hop over the asymptote, and then trace the rational function. So is this graph continuous? No, it is not. And piecewise functions are generally not continuous. It is possible that one piece and another piece connect, that where one of them ends, the other one picks up again in the same place. It's possible for that to happen, but it doesn't happen all the time. So if not, where are the discontinuities? The discontinuity where it stops being continuous, where you have to make the jump, is at x equals 1. That is where the graph has a gap that makes it stop being continuous. All right, let's try the next one. Okay, so next one I've got a cubic graph. So I'm going to type 2, x minus 2 to the third. And then can somebody tell me what the locator point for this graph would be? 2, 0. So 2, 0 is what I'm going to look for on my table. 2, 0. So positive 2, and then there's no number on the end. And so 2, 0 is my locator point. And then that's where that's how I always start on the table. That's where I always look for just the middle and then get my other points from there. Yeah. Okay, so 2 times x minus 2 to the third. I'll go ahead and graph it. It's going to look like that. And then I'll look at my table. So there's 2, 0. There's the middle. So I'm going to have 1, negative 2, 1, negative 2, and 3, positive 2. And then the points after that go all the way up to all the way up to positive 16 or all the way down to negative 16, and I'm not going to be able to graph those. So I'm just going to make this kind of look like that S-curve shape, that cubic shape. Okay, so I need to circle which value? 3, okay. I'm circling 3, okay. Based on the symbol, Should I fill it in or not fill it in? Do not fill it in, okay? And then which part of the graph am I keeping? The left side or the right side? I'm keeping the left side. So I'm going to take this, I'm going to make this part dark. Go back and erase the other part. Okay, and then x minus 4 squared plus 1. So what's the vertex for this quadratic? 4, 1. Okay, so I'll graph that, and I'm going to look for the vertex. X minus 4 squared plus 1. I'm going to look for 4, 1 on the table. So we've got 3, 2, 2, 5, over 3 up 2, over 2 up 5, 5, 2, 6, 5. Okay, so there's our U-shaped graph, and it actually goes right through that point that we just had. So with this one, we find where x equals 3, which is right here, so I circle this. And do I fill it in or not fill it in? We fill it in. So that means the previous problem left it not filled in, but we just filled it in for this one. So when you have a circle that is not filled in, it's called a hole. It's a hole in the graph. And the way you can think of this is kind of like you dug a hole, you know, like you have a, I don't know, you're outside playing in the dirt as a kid, you dug a hole. And then for this one, you dug the hole with the first problem. The second problem went and you kicked the dirt back in the hole and it filled in the hole. Does that make sense? So the default is if one problem leaves a hole and the other problem fills it in, then it is filled in. Filled in cancels out a hole that was made. Does that make sense? It doesn't matter if this one made the hole first and then that one filled it in, or if this one made the hole and this one filled it in. It doesn't matter which order it happens. All that matters is that it happened, that they ended up being connected at that same point. Okay, so this one went in and filled in that hole, and then which part of the graph are we keeping? We're keeping the right side. So I'm going to go through here, going to make this darker, erase the left side, and then is this graph continuous? Yes. So if I trace this with my finger, I can trace the whole thing and not pick up my finger. So yes, this graph is continuous. Discontinuities not applicable for this problem. All right, go ahead and flip the page. I decided to make things a little bit crazier, so here's a piecewise function that has 3 pieces in it. So if we look at the first problem, we have a cubic again. What is the locator point for the cubic? -3, -5. Okay, so left 3, down 5. All right. So we've got 1/2 x plus 3 to the third minus 5. And when we look at the graph, we're going to look for that point -3, -5. So there's our cubic shape. So -3, -5 is in the middle. Those decimals aren't too bad, so I think I'll actually graph the decimals this time instead of avoiding them. So -4, -5.5. -2, -4.5. -5, -9. negative 1, negative 1. 0, 8.5. Oh, too far. Okay. So there's that. And we know that if we look at this, negative 1 is the important point here. So I just want to make sure I go a little past that so I can really see what's going on. Something, that's the middle, something like that. So there's our U shape, there's our other. Okay. I kind of drew it well. Okay. All right, and what should I do? Circle negative 1 and fill it in. Keep the left side. Okay, so I'm going to make this darker. Erase this. Okay. Now I'm ready for the next one. It says absolute value of 2x minus 4 plus 1. Is the vertex 4, 1? No. Because it's absolute value. Not quite. So it's still going to be the opposite sign. It's still going to be a positive. It's 2. Why is it 2 and not 4? You have to factor the inside. Is because this 2 in here is making it not quite as things appear. So 2 times x minus 2 plus 1 is what you have to do first, and then you can see the vertex is positive 2, positive 1.
Why doesn't the absolute value change the
Because, so if you look back at your notes from yesterday, the vertex, the locator point, finding the asymptotes, whatever it is, it's always HK, and it's always the opposite sign. So the absolute value doesn't impact, it impacts the result of the inside. It doesn't impact numbers one number at a time, ignoring the operations inside. It's after you do all the operations inside, then it impacts that output. Does that make sense? Okay. All right, so 2, 1 is the point we have there, so we're going to type it in and then look for that on the table. And remember, to get to the absolute value sign, we hit the math button, math, go over to the second column, and it's the first one on there. So 2, 1 is the middle. Then I've got 1, 3, 0, 5, 1, 3, 0, 5, negative 1, 7, 3, 3, 4, 5, 3, 3, 4, 5, 5, 7. And for this one, we're going to be circling 2 numbers. So I'm going to circle at negative 1, and I'm going to circle at positive 4. And should those numbers be filled in or not filled in? Not filled in. And then what I'm going to do is I'm going to make it dark in between them. I'm going to keep what's in between, and then I erase everything else. Okay, what's the vertex for this last one? 5, 6. Okay, so over 5, up 6. Okay. So we have an upside down quadratic. I'm looking for 5, 6. That's the middle. I've got 4, 5, 3, 2. And then 6, 5, 7, 2.
Good afternoon, or sorry, good morning, staff and students. This is Ms. Honeycutt. Wanted to, at this time, inform you all that we do need to go into a modified.
So we put the circle on 4. Do I fill it in or not fill it in? Fill it in. And then which side of this parabola should I keep? The right side. Keeping this right over here. And then erasing this other part that I drew. Okay, so is the graph continuous or not continuous? Not continuous. So if I trace it with my finger, I do have to jump from here to here and then trace the rest of it. So it is not continuous. And what x value is the part that ruins it? The x value that ruins it is -1. +4 was really trying to make the graph continuous, but -1 ruined it for everybody. Okay, let's try the next one. So the next one starts with an exponential function, and exponential functions don't really have locator points, but they do have what? They do have asymptotes. Which kind? Horizontal asymptotes. So I'm going to look for the horizontal asymptote. Where's it at? Y equals 1. So I'm drawing my horizontal asymptote at 1 around where the x value is -4. So I'll draw it over here. So horizontal asymptote at y equals 1. Okay. And then I'm going to go ahead and type this in 2 to the negative x minus 6. Negative x minus 6. So when you type this in, be careful. Your negative is short, your minus is long. Negative x minus 6. And then plus 1. This one would be very easy to mistype. Okay, and then I'll graph that. Okay, so I know that I'm going to be looking at my negative values over here. Somewhere around -4, I can tell because the graph cuts off at -4. So -4 and then negative values that are more negative than that. So I'm just going to go up here to my negative values around -4. So I'll start, this one will be easy to graph. -6, -2 is easy to graph. -7, 3. -8, 5. -5, 1.5 isn't too bad. 4 is 1.25. This is where it starts to get more difficult. So there's my exponential graph. You can see it's following the asymptote right there. Okay. And what should I do? To the right of -4. So I'm going to circle -4. I'm going to fill it in. And I'm going to erase everything to the right. I left a little bit of my asymptote there so I can see it. Okay. Okay. We all good with that part? Okay, now this part says just a number. It's just y equals 4. This is not your typical parent function. This is going back to earlier math classes. There are a few linear functions on here, maybe. Did I do that? I don't remember. I wrote this last night while I was watching reruns of Grey's Anatomy. Don't judge me. You know what's wild? This is going to age me. Grey's Anatomy came out my freshman year of college. I remember sitting in the dorm watching the first season of Grey's Anatomy. And now there's 18 of them. It's very uncomfortable. All right, let's move on. Y equals 4. How do I think of y equals 4? How do I know how to graph that? It's a horizontal line at 4. And if you brain fart and can't remember if it's a horizontal line or a vertical line, you just have to think of it as y. The y coordinate of every point on the line is 4. So you got the point 0, 4, 1, 4, 2, 4, 3, 4, 4, 4. It's just the line where every y coordinate is 4. Okay? So what do we do now? Okay, so we're going to circle where it's at -4 and circle where it's at 0. And then are we filling in or not filling in? Filling in 0, not filling in -4. Okay, and then what do we do? Okay, so we're going to keep the insides and erase everything else. Okay. Last part. What is the locator point for this cube root? What is the locator point for the cube root? -1, -5. Okay, we're going to graph that and look for that locator point. How do you get a cube root on your calculator screen? Math, go down to 4. Okay. X plus 1 minus 5. Okay, and doesn't have to have parentheses, but it needs to be under the radical. Yeah. Okay, so I'm looking for -1. Okay. -2, -6, -1, -5, 0, -4. Ooh, 7, -3. Okay. Okay. Looks something like that. And then what do we do? Circle x value of 0. Don't fill it in. Erase everything to the left because we are keeping the stuff to the right of 0. Keeping that. Erase this. Okay. Is the graph continuous? No, definitely not. Jumps twice. No. What x values make the gaps happen? 0, so right here, that's at 0, and where's this at? -4. At x equals -4 and x equals 0.